Okay, we're going to do an example here, and we're going to look at limits as x approaches infinity or as x approaches a vertical asymptote or even a jump discontinuity. So we're going to look at a couple of examples because I know you guys are going to see stuff like this in your homework, on your lab, on your quiz, and on your test. This is a pretty important concept to understand. Now, remember, the idea of a limit is always going to be as x is approaching some number, what is the function output approaching? Okay, so for our first example here, this situation, x is approaching negative infinity. And as x is approaching negative infinity, you see the graph is going to the left forever. And it's not super apparent in this video, but or in this picture, I should say, but it will be apparent on anything I give you on the test. So the graph is approaching, in this situation, a vertical asymptote, and that horizontal asymptote. And that horizontal asymptote is at y equals -1. So since we are approaching y equals -1, the horizontal asymptote, that is what the limit value is. All right, now let's look at the next one here, which is the limit as x approaches -3. And x approaches -3 is this vertical asymptote right here, okay? So as x approaches -3 from the left and the right side, where is the graph going? Well, on the left side, as we get closer and closer to -3, but we never touch that vertical asymptote, as we get closer and closer on the left, my y values are going to positive infinity. And the same idea here, as we get closer and closer from the right, we're also going to positive infinity. So at that vertical asymptote at x equals -3, the y values are approaching positive infinity. All right, our next example here, C, D, and E are all dealing with x approaching 0. X equals 0 is another vertical asymptote. So I've got another vertical asymptote here at x equals 0. And we want to look at what happens as we approach 0. This little minus sign means from the left. The plus superscript means from the right. And then we have the general limit. So if you notice the left and the right sides, as we get closer and closer to 0, if I'm tracing the graph approaching 0 from the left, my graph is going down forever. And if I'm approaching 0 from the right, my graph is going up forever. So in this situation, as we approach from the left, that limit, the y values, tend towards negative infinity. And as we approach from the right, the y values tend towards positive infinity. So when we look at this here and we look at the general limit, because those two limits do not match, negative infinity is not the same as positive infinity, the limit here does not exist. The general limit doesn't exist, but the left-hand limit and the right-hand limit, even though infinity doesn't exist, they have direction. We are approaching a direction, and we use positive infinity and negative infinity to indicate that idea of a direction. Okay, so now let's look at -2. So F, G, and H here, we're looking at the limit as x is approaching -2. Another vertical asymptote, well, not really a vertical asymptote. In this situation, we just have a discontinuity at x equals +2. So as we look at approaching 2 from the left and the right side, so 2 from the left and 2 from the right, you notice that we're not approaching the same number value. So from the left side, we're going towards this point here, and the point from the left is going to be y equals 1. Whereas from the right, the point we are approaching doesn't exist on the graph. It's an open hole, which means we can't touch it. But remember, limits are the idea of what we are approaching. And we are approaching from the right side. That's what that +2 indicates. We are approaching y equals -3. And of course, because the left and the right limits do not match, in this situation, the general limit does not exist. All right, let's see. Example I, we're going to look at the limit as x approaches +4. +4 on the graph is this point right here. And as we approach left, or approach 4 from the left and the right side, you can see that that y value is going towards +2. And +2 is a defined function value on the graph. So if it's not an open circle or a gap, then it is a defined value. We don't draw solid dots on the graph everywhere, but all of those points exist. Whereas right here, where we look at this point, we can approach that point forever, +2, -3, but we're never going to touch it. We can get infinitely close to it without touching it. And that's the same with our vertical asymptotes. Okay, our last example here, we're looking at approaching +infinity. So what does this say? As x goes toward +infinity forever, where do my y values go? And hopefully you can see here as we are approaching +infinity, as x goes +infinity, my y values are approaching this horizontal asymptote at y equals 0.